let's cover how to fit a model. Once we define a model and we have a population, I'm using the Pharma data sets to import a data set that we use for IV single dose. This is the data set, IV single dose. It looks like this. So it is a non-man formatted data set. And we read into a population. Once we do that, to call the fit function into a model, we need 4 things. We need a model that we already have. We need a population, an initial set of parameters that we define as a tuple, name it tuple. So here I'm saying TBCL equals 1, TVVC equals 10, and omegas is a diagonal matrix with 009s in the diagonals, and sigma equals 3.16. So this is how I specify our initial set of parameters, and I save this to the params variable. And finally, we have the 4th argument is Puma's inference methods, estimation methods. So we have FOC, that's first order. We have FOCE, that's a first order conditional estimation. And you don't need FOCEI. FOCE will automatically detect any interaction, and if so, we'll use FOCEI under the hood. We have Laplace I for Laplace estimation method, and we also have knife pool if you want to have a knife pool without random effects, and then you specify as a keyword argument the omegas equals my omegas as a symbol. So let me run those for you to take a look. So if we run the first one, we get a trace. So let me just scroll back to the beginning. So we have our iteration, the function value, and the graded norm. And this will go on until the model converts, until the graded norm from the last iteration, it is below. The difference below the last iteration for the graded norm is below a certain threshold. That means that the Pumas has converged, and we get back that we successfully minimize the likelihood function. And this is true. We get the likelihood approximation method that we use, that Pumas FO, the log likelihood value that we arrive at, number of subjects in our population, number of parameters that we are optimizing, that we are estimating. We haven't set any fixed parameters, so these are 0 for fixed and 5 for optimize. And total number of different variables, observations, it's almost 1800. And we get the maximum likelihood estimates. We can call this again with the FOC. It will also run a trace for us, and we have the same output as before, but now the estimation method, the likelihood approximation, is the Puma's FOC. We can do the same with the Laplace I. We get a trace, and we get the same output, but now it's Laplace I. And we do the same for the knife food. That was pretty fast. And we get the likelihood approximation as knife pool. So that's how we fit a model. You call the fit function. You need 4 position arguments: model, population, parameters, and your approximation likelihood method. In this case, you can choose 4 of those: FOC with automatically FOC interactions, detection, Laplace for Laplace I for Laplace approximation, and knife pool if you want to take it out the random effects.